CNT120, Chapter 5. We're continuing our sectional and twisted pair. Here I just put a reminder in of our phone cabling RJ11. In this case it's a 2-wire, but phone wire was typically 4-wire. 2-wire for houses, 4 wires for like small business kind of thing. Our network cabling, 8 wires, twisted pair cabling, 8 wires. There's my RJ45. There's my RJ45. So you can see where the development came from, but this is where this is what we use for our twisted pair termination. Now, terminating twisted pair, we have 2 pinouts that get used. Typically, 568A is commercial, 568B is home and other areas, other types of networks, if you will. And I have my 8 wires laid out in a specific color code order. That way, the send pin on my computer gets to the receive pin on the switch, if you will, and vice versa. The send pin on the switch gets to my receive pin on my network card. That's why we have to have things laid out in order so things will communicate. So with my pin out here, I see the orange pair here in the 1-2 spot. I see the green pair in the 3-6 spot, the blue pair in the 4-5, and the brown pair in the 7-8. Now that might look weird, but this was originally designed that these 4 in the middle could accommodate a phone cable. That's why those work together. A phone cable, these 2 wires here in the middle are line 1, and the 2 on the outside are line 2 on a phone. So these 4 in the middle are designed to accommodate a phone connection, and that's why we have a pair out here in the end, 2 in the middle kind of split, and then a pair out here on the end. That's why that's done. Might look weird, but it was for a bigger purpose. So there's my 568B color code. Unfortunately, I don't have a sneaky little rhyme to help you remember the color code order. And then here's your 568 color code. And you'll notice really the only thing difference happened is the orange moves here to the 3-6 spot and the green moves to the 1-2 spot. That's the only difference that occurs. Blues and browns stay in the same spot. Here's my pinout 1 through 8 with a little clicky tab on the back. These brass pins here are 1 to 8 left to right when I have the clicky tab on the back, and that's what it's showing here. Clicky tab on the bottom down there, pin 1 to 8 here. I have a couple different examples, so whatever helps you see the color code, I put them here for you. Here's your A color code on your left. Here's your B color code on the right on this one. Anytime we terminate in our lab rooms, we just use B. I use that as a, hey, Mr. Brown, color code B. That's probably what you would end up doing, so that's why we use that one too. Here's your A color code over here. Here's your B color code here. This is showing, here's the patch cable. Here would be the outlet that it's plugging into. This would be the outlet on the wall that you'd be plugging into, just so you can see the little notch down there. That's where the little clicky tab goes. I would see the color code here. It's the same color code, just showing you in the outlet form what it would look like. Remembering fast Ethernet, I'm using 1 pair send receive. Gigabit, I'm using all 4. Gigabit, I'm using all 4 wire pairs. Alright, when I deal with cabling, I typically deal with patch cables, a cable to connect 2 things. Patch cable is a relatively short cable with our connectors at both ends for connecting. Usually, if I have poor terminations, this is where I can have some noise, interference, and crosstalk occur. So proper cable termination is key. So, the types of cables I run into are straight through, crossover, rollover. So let's talk about those. Straight through cables are used to connect unlike devices, things that are different. So switch to router, switch to PC, switch to server, that kind of thing. Unlike devices, devices that are different. Unlike devices, that's what your straight through cable gets used for. Here is the pinout for a straight through cable. Both ends are wired identical. 1 to 8 on this end is the B color code. 1 to 8 on this end is the B color code. Identical on both ends. Everything is wired straight through. A crossover cable is used to connect like devices, similar things, like devices, similar things. So switch to switch, router to router down here in the bottom, or PC to PC. So if I'm connecting switch to switch, I'm going to use a crossover because the switch, example, the switch pin number 1 might be send. So if I connect pin 1 here to pin 1 here, they're both going to send on that wire and they're going to have collisions. So I need to make sure that pin 1 send over here gets connected to pin 2 receive over here, for example. So a crossover cable is designed to connect the sends on one device to the receives on the other device. So that's why a crossover gets used on like devices, switch to switch, router to router typically. That is your crossover cable. And a crossover cable, if I look at it, this is a gigabit crossover cable here. These are actually both gigabit crossover pinouts. I have the orange pair swapping places with the green pair, and then the blue pair swapping places with the brown pair. So I literally have both, all 4 wires swapping, but the orange and the green swapping, and then the blue and the brown swapping places. So I'm getting my sends and receives connected. The last type of cable I have is a console cable or rollover cable. Console cable or rollover cable. Right here is an example of a console cable. This is the kind of cable we use in our lab room to connect to the PCs in our room, the serial cable and the serial port in the back of our PC, or I have a serial port adapter, okay? So connect to our PC and then into the console port on something like a router or switch. The commercial router and switches that we use, not your homeowner router and switch, the commercial router and switches that we use in our lab room actually require you to connect a PC into it, into the console port to type commands to configure it. I literally need to use a command prompt type of interface where I send commands to it and it responds to me. And that's done through this console cable, or it's called a rollover cable. That cable is wired in this manner, where literally pin 1 here is wired to pin 8 over here. Pin 2 here is wired to pin 7 and so forth. 3 to 6, 4 to 5, 5 to 4, 6 to 3, 7 to 2, 8 to 1. The whole entire cable is rolled over, hence the name rollover cable. That is a special use cable, but we do use it in our networking classes daily. We use this daily in our lab room. This would be the kind of thing you might have in your laptop bag to connect your laptop into the router or switch in your networking closet. That's your console cable. All right, Power over Ethernet. Before we get too far away from anything twisted pair, Power over Ethernet is a standard that allows you to supply electrical power over a twisted pair cable. So things like my switch could actually power devices like, let me slide out here, things like IP phones, access points, and cameras. And here's the idea. Things like a security camera, things like an access point, I don't want to put them where I have a power outlet, because that might not be where I need the camera to observe, the door coming in out of a building or the door coming in out of my wiring closet. And I don't want to put the access point where there's an outlet, because that might not be where the center of the cafeteria is or the center of the auditorium is. And actually phones are not much different. I want to make sure I'm powering the phone so that no matter what, if the power in the building goes out, I'm getting power to it. I'll get to that in a second. So devices like my switches can power those devices so that I can put them where I want them, not where I happen to have an outlet, electrical outlet nearby. So my devices like my switches can power those units. When I buy a switch or spec out a switch, I need to look at its capabilities. They have them listed somewhere, when you're looking at the specifications, and it does have a wattage limit on how much it can power. Now, 740 watts is quite a few devices, because things like your access points and so forth might only be consuming, 15, 20 watts kind of thing a piece. So I could have quite a few of these, but I do need to make sure my switch has enough power to power whatever I'm trying to plug into it. And things like these are things that I'm going to power. And again, I want to be able to power the camera from the switch so I can put the camera where I need it, the access point where I need it. And I also want to power my IP phones, because if I had to plug this in a wall outlet, when people move their office around, they might forget to plug their phone in. All of a sudden, their phone doesn't work. And I say that because people move their offices around. Secondly, I want to be able to power it from the switch, because if the power in the building goes out, my phone might go off. However, with my switch, I'm probably I should be using a battery backup on this to keep it running, even though the power in the building goes out. And then the generator is powering my battery backup unit. So if the power in the building goes out, my switch is still functioning and can still power the phones in case there is an emergency. Somebody falls and hurts themselves, I can still pick it up and call for help. I can call security, 911, whatever, and call for help. So even phones, I'm going to want to power from devices like a switch here. So there is a standard for that, and I can actually buy my switch that'll do this. It is going to cost more money to buy that, but these switch ports will power those devices wherever I need them. If I don't have that kind of switch, I can use a power injector. The power injector will inject power across the unused data wires, out to that device and power it. Once upon a time, we used one of these in our church to power an access point that we hit above the ceiling downstairs in the children's area. We don't want the children hitting it, so we kind of hit it above the ceiling, but we use that to get power out into the room where we put that access point. And here it shows you some examples of power over Ethernet switch, powering our cameras or access points, or I can actually use an injector. I can actually use a power injector. The data moves through there and the injector adds the power to it and pulls it off to power that device. And it does work. It does work well. So there's your power over Ethernet. Before we move out of twisted pair, let's mention our standards. These are fairly easy to diagnose or tear apart, if you will. If I think of this format down here, when I see a standard 1000 base T, there's 3 basic parts to it. The first part is your bandwidth. So that first number is the bandwidth. 1000 would tell you 1000 megabit. The base in the middle is baseband as opposed to broadband. Baseband is 1 signal on the wire per time. Baseband is 1 signal on the wire per time. Broadband, on the other hand, is multiple signals on a wire per time. Think about your broadband connection to your house. The broadband connection to your house probably has television signaling, data signaling, and might even have phone signaling. Those are 3 different signals coming across that cable at a time, hence the term broadband. In networking, in Ethernet networking, we run into baseband signaling, 1 signal per time. The last denotion out here, TP or T, is letting us know twisted pair. T is letting us twisted pair. So these now become super easy because they all end with base T, base T, base T, base T. The first part tells us our bandwidth. So 10 base T is Ethernet, 100 base T is fast Ethernet, 1000 base T is gigabit Ethernet, 10G base T, 10 gig, 40G base T is 40 gig. They're all pretty much designed to go 100 meters. The upper standards are designed for shorter distances because of the signal frequencies that they're using. And here lets us know with the standard, if I'm going to do 10 base T, I can do category 3 or better, category 5 or better for 100 meg, category 5 or better, preferably 5E for gigabit. 10 gig, I'm looking at category 6 or 7. And then 40 gig, I'm looking at category 8. Okay, so there's my Ethernet standards for twisted pair. Those are pretty straightforward. You do see this, especially if you were to, let me zoom back here real quick. I'm going to look at this switch back here. If I were to zoom in on this switch right here, above these ports, a lot of times you'll see denotions of 100 base T or 1000 base T, letting you know what is the capability of that port, 100 meg or gigabit, if you will. So you'll see that printed on things. So these are worthwhile to have kind of in your back pocket. All right, as we move on, next section we're going to move on to fiber optic.